Alright, today I'm doing multiple regression, um, and I've here everything is. Ignore all these numbers; it looks crazy. So you're going to go to analyze. You're going to go to regression. You're going to go to linear. So for the very first task, it was the social anxiety regression data set. So I put social anxiety and the dependent. And then I did shame in the first block. And in the second block, I did the interpretation and the obsessive. So for the statistics, I did model fit, R-squared change, descriptives, collinear diagnostics, estimates, confidence intervals in the Durbin-Watson. I'm saying that right. And then right here goes the Z residual, and right here is the Z pred, which is basically predictor, and the histogram, the normality plot. And I can't remember if this was checked already or not, but I did this. Produce all partial plots. Press continue. A bunch of people did a bunch of different things, so I'm kind of confused on which one I'm supposed to do. But so I did unstandardized, standardized, adjusted, and then standardized over here for the residuals, and then standardized degrees of freedom betas, and then standardized degrees of freedom fits, and then the cooks. And I'm thinking Dr. Grande maybe did the create coefficient statistics, but I'm not going to do that. And then press OK. And then for social anxiety, we get this beautifulness. And I'm not going to explain this because I'm thinking we talked about it in class or something. But yeah. So I went on to do another regression for the the supermodel.sav file, and this is the one I'm going to explain. Okay, so the very first question is how much variance does the final model explain? So for the first model, 15.8% of the variance is accounted for in the first model, and then 18.4 is accounted for the variable. And there's this much difference between the two. So there's only a 2.6% difference between the models. Mm-hmm. And let's see, the next one. Next one is which variable significantly predicts salary for age? Okay, so significant wise, age is significant right here with less than 0.001, and the number of years as a model is 0.009. Attractiveness is not significant, so it's not significant with predicting salary. This had a negative, a negative correlation, and this has a positive correlation. Yeah. And the regression equation for the final model is salary equals b sub 0 plus 6.23 times age minus 5.56 times the amount of years minus 0.196 times attractiveness. Instead, are the residuals as you would expect for a good model. And I think no, because I kind of expected more of a change between it. And honestly, I'm really surprised that attractiveness, had such little effect. What is it? The next one is there evidence of normality of errors, homoscedasticity, and no multicollinearity? So I got this, right? And this is skewed, and you can tell there's outliers, right? And this right here, it ain't straight. It's curvy. So then I ran this to see what it looked like. And, well, it looked weird. Um, yeah, so there are some crazy outliers. It's not normal. It's curvy and weird. And there's all the outliers. Um, and I mean, not a bad pancake, but not, a good one. It shouldn't be pancaking at all. And this is significant, therefore, it's not normal. What was the last thing? Oh, yeah. So I want to say this, even though I'm not really sure. So when I was watching Dr. Grande's thing, it said that this had to be from, for cooks. This one right here, the maximum had to be less than 1, which is true. And this right here, it was -3 to 3, and this goes outside of it. I'm not really sure what that means. I'm not sure if he was talking about multicollinearity, but yeah, I'm just saying that, like, I checked, and that's not right. So, like, I don't know what's wrong, but I see it. Um, I think it may have been multicollinear.